Great. Good day, everyone. It's good to have you back for our third session of our tutorial that takes place on Saturdays. If you feel like you missed a lot of stuff that we covered last time, let me just give you a recap of what we did. So last time we'd look at different data structures that we have. There was like a quick look into what pipes are. So that's what we're going to try to cover this time around. But before we do that, we're going to try to cover basic operators that we have in R, right? But just a recap of what we did last time. Last time we had to look at data structures, and then we say a data structure is a format of how you organize or store your data, and you can do that either as vectors, data frames, matrices, and arrays. And then we managed to go through each of the data structures and gave you typical examples of how you can create one, how you can store one, and how you can organize your data into one. So if you feel like you missed all that, just go and look for the tutorial before this one and just go through it. It was well explained, so you wouldn't go through much of a hassle in terms of understanding all the content that we managed to cover in that tutorial. And then we had to skip on and talk about dating time and how dating times can be read in R, how to manipulate them, how to change them so R can understand what you're dealing with. So it's really one of the most important things that you also need to understand in R programming, just in case you happen to have data that R cannot understand or interpret based on how it has been given to you or how someone had to record it. So you might need to make sure that R can understand that. So also feel free to go through that and then just cover that part. I believe that is all. So today we're going to try to cover what we call basic arithmetic in R. So let me just type that one out for you. So we have basic calculations. Calculations, that's a very wrong spelling. Calculations in R, right. So for basic calculations in R, we're going to do a lot of additions, we're going to do a lot of subtraction, multiplication, division, and so on. And you might need to understand how we get to do that, right? So there are a number of operators that we make use of. So we have arithmetic operators, we have logical operators, we have conditional statements, and so many other things, right? But today we're just going to look at the basic stuff of all these things and just give you a little bit of a peek of what it's like to do around with calculations in R. So we managed to talk last time about assignment operators, right? And we said whenever you have to assign a value to R, let's just go a value, Shona, make use of the following assignment operators. So that is that arrow, right? And then I give it a value of 5. And then if I press enter in the console, it's able to have that stored within the environment where I can see it here. So that's how you deal with an assignment operator. So an assignment operator kind of helps us out. It may be saving out certain functions that we would have created or certain values that we would have made so that we can just call upon those values later on instead of going through the whole process of maybe calculating that value again or maybe how we saved it and stuff like that. So it skips all that and just saves the process of the steps that we took for us or the value that we are producing or the result that we produce and just save it as a variable so we can always call upon later on. So if I were to say value here and then press enter, right, within my console, what I get is 5. So that means there's no reason for me anymore to type 5 every time I need to make use of 5. I can always say value, then it gives me that output. So if I had done some number of calculations and then store them as value, I'll just need to call upon value and then it will just bring back whatever result I had made from all those calculations back to me. So it makes it a little bit easy for us whenever we have to maybe use that again later on in our programming or in our coding or in our analysis, right? So that's the whole basic thing around it. So that's the assignment operator. And then we have to talk about, I'm just going to copy this so that I don't get that again and then clean it up. Okay. And then we have to talk about arithmetic operators. So I've done with the assignment operator. And then we have arithmetic operators. So with arithmetic operators, these are basically calculation operators that we use, right? And you're all aware of these ones. So we have the addition, right? So we have the addition. Let's start with the addition. We can find addition. We have got the subtraction operator, wrong one. We have got the multiplication operator. And then we have got the division operator. So this is our division operator, right? So all these can be used when you want to, let's say, when you want to do a lot of calculations, right? You can either add, subtract, multiply, or divide, whatever you want to do with it. So the first thing that we're going to do now, so that you can have um, a pretty understanding, a basic understanding of how this can actually be put into your work. So I'm just gonna maybe have a new script here, save a new script so I can save myself and I don't have to keep clearing that up. Okay, so I have a new script. Let's just save it as a cells. Yeah, just cells. And then I'm gonna assign this one to the following variable. Let's say first quarter, second quarter, and things like that. So we're gonna play around with this, right? So for ourselves, let's say for first quarter, let's start with the first quarter. First quarter, we had something like assignment operator. We made cells, listen, in a year with 4 quarters, right? It can be divided into 4. So for first quarter, let's say the first 4 months we managed to have $5,000 sales, right? Let's make them $50,000 sales. That's all I managed to have. Is that 50? 1, 2, 3, that's more than. So just gonna get rid of 1 0 here. We had 50,000 sales that we generated as a company, right? And then in our second quarter, let's say for second quarter, in our second quarter, we managed to generate say 10,000 sales. But well, the company was getting known now, it's getting popular and things like that. And if you want to understand what I mean, yes, sales, media sales, media sales, right? So if we were to have a quick addition of the following things, first quarter, right? I love how this one can actually get to finish it out for me. I don't have to start it. And then we add that to our second quarter. Thank you so much for that. And then I run it. So how you do it is you have to underline everything in here or highlight it so that I can understand that you need to run this and then this one and then save the variables and then be able to perform the last step. So if I were to only run the last step, it's always going to give me an error because it doesn't understand where first and second quarter are coming from, right? So you need to run everything so it understands that we're coming from step 1, step 2, and now we're on step 3, and you calculate what mid sales is for me. So I'm just going to run this one. And this is how you run it. And then we've got our variables coming here. So for mid-year, we managed to have 60,000 cells that were made. So 50 plus 10,000, actually, we had a loss here. We had less cells than what we had in the first quarter. So that makes it 60,000 cells that we had for mid-year, right? So let's say in the final year, or year end, let's just have year end. So for okay, wrong one, where to put it. For year end sales, we managed to have double that, right? So our sales doubled by what we had in the mid-year. So what we can do is we can have mid-year and then have this one multiplied by 2. This is gonna have a 2 multiplication by 2, right? Then if I say media, and then if I just run this one, since all these values have already been saved, I don't need to highlight everything anymore because they're already within my environmental pen here. So I'm just gonna run this one. It's gonna tell me that since we had 6 by 2, that makes it 12,000. So for end of year, we managed to have 12,000 cells that we generated. So that's how you use the addition, the multiplication. And if you want to have the division, you can actually do that. Let's try to see what we can do with our division here. So for our division, I'm going to choose something different here. Let's say average sales, yearly sales. Okay, we're typing of this. The yearly sales. Then I'm just gonna put that sum and operator again. And then I'm gonna have year-end sales divided by 4. Let's see how much, if we were to look at the average, where we're making within each quarter. So I'm just gonna highlight this one, then I'm just gonna run it. And then I'm getting an idea that we were generating 30,000 cells each quarter. So if we were to look at each 4 months within a year, we're basically generating each 3 months within a year, right? Yeah, each 3 months within a year, we're generating 30,000 cells, right, per quarter. So that's how you get your division sign working here. And then what's the last one that I haven't covered? Looking at the subtraction, we can actually do that. If you want to see, let's use the subtraction here. So for our first quarter, uh, sales difference within a quarter, right? So we're gonna sales difference. Let's say mid-year sales difference. Mid-year sales difference. I'm gonna say first quarter. First quarter. Subtract second quarter. How come it didn't show up here? This could be due to my network, obviously my network. So it's supposed to be done like it. Second quarter, there we go. So for sales difference, you see how we did, how we performed. Yes, so I'm just gonna move this one. Then look at media sales. What is this one that I'm looking at? There we go. So for media sales difference, right, there was a negative of 40,000. A negative of 40,000. I was supposed to start with the second quarter and then start with the first quarter, but I just had to start with that one first and second, that one. But the idea is that you can see how you can make use of your addition, your subtraction, your division, and your multiplication calculations within. So right now I'm using a script. I was trying to avoid using the console because if you make an error, you won't be able to fix it up. But here I can just do the edits and then fix it up for me. So a script has got a number of advantages. I'm going to cover that in our first tutorial. It ensures that you save your code. You can always run it later on. Because if I close the terminal, I'm also going to lose everything here. But with the script, I can actually just save it and then be able to run it later on. So if I go on file and I say save as, I've got like a number of options that I can use, but I'm just gonna use save. It's gonna ask me what name I want to give to this one. So I'm just gonna call my sales script. Sales script. I think that can work. Sales script. And then it's gonna put in R on the end, right? So making it an R script. That's what it is in R script. There's a Python script, ends with a pi, nano script ends with a capital letter R, right? Okay, looks like that's about it. So that's how we deal with arithmetic operators. That's what we have to cover here. Just gonna copy this one up. I'm not sure if it's not gonna give me any errors. All right, let me just copy it and save it in my script. I think that can actually work. Okay, let's see. Yeah, I'll probably run into errors. So let's just save this one in our script. Oops, I can't do anything now. There we go. Okay, let's have it here. Okay. Yeah. That's making sense. Oh, it's making a little bit of sense. All right. So this is for our first calculation. Then the second one that we have to cover here is the logical operators, right? So we have to go on and cover the logical operators. Just going to do that, then have logical operators. So for logical operators, we understand that we'll basically be dealing with I'm gonna go through it. So let's start with this one. Not. All right. So when we have not for logical operators, is not is represented by the following arrow. So when you say something is not, we're gonna probably get a false, right, or a true value back. So logical operators, they actually play around with true or false results, right? That's what you're gonna get back. So if you're going to use a logical operator, that's or a logical statement, it's going to be evaluated to either true or false. So if I say something is not, right, we don't use the latest though. So we mainly use don't use the words, but we use the symbols, right? So for not, for since that is not equal to that, we make use of this symbol. That's what R understands. Then the second one we have got uh, let me just run through all of them so that we never have to skip this one. We don't go through it. Then we've got and, right? So for and, yeah, I'm just gonna put and here. So and is represented by this arrow, right? And then we have or. Or is kind of different from how we use this logical arithmetic operator. So for or, we're gonna have to use this sign. So it's like a vertical line that we make use of instead of having this one with that vertical one. It's very straight. That's the one that we make use of. In fact, all arrows in here are actually straight, but yeah, that's not. I'm just trying to give an idea of how we can actually make use of it. So let's just put this into practice so you guys can see what we're dealing with here. I'm just gonna get rid of this stuff so that doesn't affect what we're covering here. So we have things such as, like I said earlier on, from logical operators, we have logical statements, right? So logical statements actually referred to as conditional statements, because these statements are going to be evaluating to either true or false, right? So let's just give you an idea of what it's like to run these things. I'm just going to jump to my console and then say, if I were to have true, so we make use of capital letters. So true and true. So it's evaluating both sides and checking if we have true and true, what are we going to get back, right? Looking at us, what are we going to get back? So in order for you to get a result that says true and you're using and as your operator, both sides must be true, right? So if both sides are not true, you're going to get a false. But if both sides are true, like here, this side is saying true and then the other side is saying true, so that means I'm going to get a value that says true. Let's have a different one, say true and false. So you guys can have an idea. So one side has evaluated false. So whenever one of the sides is no longer satisfying the condition of both being true, our response will automatically become as false. So if I enter this one, I get false, right? And then if I try false, okay, that's wrong spelling. False. Okay, me trying to use letters in there. False and false. If I get this one, I get a false, right? So you can only get a true if both sides are true. So it's like saying, okay, we're gonna cover it, but it's like saying we need someone to have the following email and the following password for them to access the system, right? So if the email is wrong, you're gonna get an error, although the password may be right. The same that applies if the email is right, but the password is wrong. You're still going to get an error, right? So it needs both to be true. Your email and your password, they have to be correct. So you can actually use this when you're setting up a system, a login system that ensures that the right credentials are going to be entered. So that's one way you can actually apply this one into a system or something that's functional for you, right? And then we have to check on the, so we covered the AND operator, right? We're gonna cover now the NOT operator, right? So if something is not, just gonna do this one. So if it's not true, automatically becomes false. That's the answer that you're gonna get, right? So I say not true, I'm gonna get false. If I do vice versa and say not false, I'm gonna get true. So whatever is going to be evaluated within that statement, if you say it's not true, right? Is the condition not true? If it is true, it's gonna give you, you're right, it's false. If it is false, it's gonna do vice versa and give you that reply. So whenever you use not is just getting the opposite of what you're going to get. It's gonna give you the opposite of that reply, right? So that's how we deal with the not operator. And then we have the or operator. So with the or operator, we're basically looking at least one of the conditions has to be true, right? So we use true or true, right? We're going to get the value that says true. But what if you say false or false, right? So on this one, what we only need is one of the sides. Okay, this one I'm going to get false. But then what about false or true? So on this one, that's where it gets a little bit exciting, right? We only need one of the conditions to be true, right? So I'm saying it's either the, so you might set up a system that basically just says, if the password is entered correctly, it doesn't matter if the password is in caps lock or it's in lower cases, right? We want it in upper cases, maybe either in upper cases or in lower cases, right? You can set up a system that can allow that so that if a person is typing that password and they make a mistake, maybe of putting a capital letter where there is a small letter, right? The system will still log them in because it has been told that it doesn't matter if the password is either in upper cases or in lower cases. So you can say it's either in upper cases or in lower cases do allow the user to log into the system. So if I press enter here, I'm going to get a reply that says true because I only need one of the conditions to be true. So that's where error is kind of different from and. And needs both statements to be true, but error only needs one of the statements to be true for it to give you a true. However, it needs both statements to be false for it to send you a false answer, right? So that's where it comes into. So now you have like an idea of how to use these ones. Let's talk about conditional statements, right? So I've given you an idea of how you can make use of logical operators. Now let's talk about logical statements. Now, let's see how we can put that one into action here. So conditional statements can actually make use of an if statement, right? Let's say here, if I'm going to need to get a data set, right? Let's just get a data set here that we can look into. So the data set I'm going to choose here is the A quality data set. So I think I already have this one within my R console. So A quality, perfect. It's already in there. Then I'm just going to run it. Just going to run this one up. Run this one. Looks like I have it. Now, once I have it, I'm just gonna have a quick view of what my data set looks like. The equality. Right. Let's run this one. Fantastic. So this is what we have for our data set, right, of the air quality. So if the ozone with the solar radiation, I'm assuming that's what it means, the ozone layer, solar radiation, wind, temperature of the day, month of month, in this month number 5, in day number 1, right? So we're going to use the things that we have covered, right? That we have covered here into application for a data set. So you might happen to have such a data set and you might need to understand some things or get a visualization of what's within your data. So that's what we're going to cover here, in this tutorial. So let's say you have an if. So this is how you use conditional statements. Okay, now that I have my data set, I don't have to worry much about this. And since I ran it, it's already been saved here. I can actually get rid of whatever is above for me, but I'm not going to do that. So we can always look at it. So if, okay, this one is going to keep running. Okay, no need, because I'm not going to highlight it. So we use the if statement. If statement is going to evaluate things within our data set or within the conditions, right? So saying if something is right, then bring back or print something for me. So this is the if statement that you can actually make use of in Python. Like I said earlier on, if you get to understand some basics of our programming, you'll be able to understand even more complex programming languages out there like Python programming, right? Because the knowledge is can be transferred to other programming languages without much of starting from the ground. You can easily just adjust to the other programming languages. So the if statement gets to evaluate whatever we have within it. So these are like conditional statements. We want to see if a condition is going to be true or false for it to bring us back results. So we want to get our results if it satisfies to true. Otherwise, if it's a false, we won't get anything back at us, right? So I have a quality as my data set. I'm just going to use that a quality, right? In A quality, we covered last time about the extraction operator, which is the one that I've just covered. So if you feel like you missed that, always feel free to go back and watch what it's all about in our previous tutorial. Okay, so it's well covered in there and documented. Just watch the videos and you'll be caught up with whatever that I'm doing right now. So for those that are just skipping to this part and they might need to understand what exactly I'm doing here, I'm just going to explain it in a moment. So let's just say temperature is 810. I'm going to run this back again so you guys can have a quick look of what it looks like. So can you view data for me? Good. And then here, I am asking if I want you to go into the data set, A quality for me, right? And then check the first within the first row, right? So this is our first row. Number 1 comes our first row. This row, this row, this row come into here. That's our first row. So within our first row, I want you to look at the number that is in line with temperature. All right, so we're going to go back, look at where temperature is. This is temperature. So that number is 67. So within our first row, we're looking for number that aligns with temperature, which is 67 here. So on 67, right, and then I want you to evaluate that number, right? I want you to evaluate that number and see if it is less than 18. Right? See or check, compare the two and tell me if it is less than 18. So if you find it to be true, what are you going to do next? I want you to print the following statement back at me, right? So how do you put that into context? So we do this one, then you press enter, right? So I have the following curly braces that I've put in. And then I'm just going to enter in here, print for me the following statement. Whenever you use print statements and you want to have strings outputted for us, we just use the quotation marks, right? Then print, it's not a whole day. It's not a whole day. A whole day, right? So I'm just going to run this one and see what value I will get back. That will be returned to me. So if I run this one, I'm being told here's the print statement that just took place. It's not a whole day. So I have to put this one up here. It's not a whole day. So let's say this was like 14, right? So if it is like 14, what's gonna happen? Let's run it again and see what's gonna be returned back at us. Like I said earlier on, it only retains true values. So all negative values or all false values are gonna be returned back at us. So if I run this one, nothing gets to be printed, right? So it ran this whole code. Sorry, ran this whole code, and then failed to output something for us because it evaluated it to false. Why? Because if we go and check that temperature again, here on equality, it's 67, but 67 is not less than 40, it's above 40, so it becomes false. False cannot be printed for us. So what happens if you want to view something about a false statement, right? That's where we get to introduce. So if can walk around with an else statement, else, I want you to print. So I'm just gonna have our curly braces again, then press enter. I want you to print. It's assumably cold today. Hot. So it's about 40-ish hot today, right? So if we're having a gauge and saying 40 degrees Celsius, if anything that is below 40 degrees Celsius is cold, anything that is above 40 degrees Celsius is hot, right? So if we're having that medium or having that gauge, anything that is above 40 is going to be read as hot, right? So I'm just gonna run everything now again and see what gets to be printed back at us. So yeah. So a false statement has been printed for us. So whenever a true statement fails to be printed, the else statement will be executed, and whatever within the else statement will be the one that's gonna be returned to us. So it's assumably hot today because we've kind of gave it that information. Like if you fail to satisfy the first condition, I want you to satisfy the second condition, then give us that result back. This is like a typical example of what you can do with it, right? But let's say you want to go deeper, right? You want to evaluate a number of degrees, right? It's not just 40, less than 40 and above 40. You want to go maybe in the middle and say something within the following range. I want you to print the following statement back at me, right? So we're going to do that. Let's introduce the else if statement. So right now we've introduced the if statement, we've introduced the else statement. The next one is the else if statement, right? So for else if statement, I'm just gonna get rid of all this. Now let's just have it here. Okay, just get rid of it and then just type everything from the ground up. Okay, so else if, let's say this assign a variable ozone dash layer, then assigning the following variable, let's say for air quality that we had, air quality, look at our first digit that we did earlier on. So within the first one, I want you to find ozone. So doing something a little bit different. Go under the column ozone. So the column that I'm using in strings, these are the columns. Whenever I have to use strings to help my extraction, I always have to use quotation marks and then make use of the columns. And the columns are the one that comes after the comma, just in case you missed all that. So ozone, you're looking at the first row and the value that is under ozone. So ozone is the name that I'm using, ozone here. So the first one will be 41, right? That's the one that we're looking at. So that's been assigned the variable ozone. So 41 has been assigned the variable ozone. So what are we going to do with this one? We're going to do a number of if else statements, right? So if, let's say the first one, if, and then we're going to do this, if ozone, let's just say, is the value that we're going to get if our ozone layer is a null value, like we didn't type anything or there's nothing on it, right? So if it finds a 0 or maybe a null value on it, ozone dash layer. So if this one were to be equivalent to a 0, right, or there was nothing that was entered, we want you to type the following things. So if you want something to be printed, use the curly braces, print. So what you're going to be printing, ozone reading, missing, right? That's if it's equal to 0. So I'm just going to put a 0 there so you guys can see the difference. So let me just copy this so that I type it again. And then just say 0. But that's a number. We need something that is maybe NA. Something that's maybe an NA. Let's see if something would come here. Okay. Let's just run everything and see if this one would work. If it doesn't, we might have to find a number that kind of would give us this one. And I need a new valid number here. Let's just leave it without anything, right? Then just run it. Okay, this was already saved. My bad then. Yeah, I've already saved it. Okay, let's run it one last time. See what we get. Of course, this object cannot be found because it wasn't assigned any value. Anyway, just trying to give you an idea of what you guys would probably get if you had entered an invalid number. Let's say here on our array, we've decided to give it 41, right? So let's say there was no value, doesn't not applicable. I'm looking for that. Oh, actually, I can do it. There's 10. So 10 is there. Let's give me this area. So 10. Let's just bring back what I copied out. Right. Then assign this one to the following variable. Let's put 10 here. So we have 10. Bit too late on that. So 10 is not a value. So I'm just gonna run this one and see what gets to be printed for us. So ozone is not a value. So get ozone reading. Ozone reading is missing because we kind of asked if dot NA is not the ozone value that we're gonna get here. If it is not a value, NA not a value, print the following back at me, all right? And then which was 10, and 10 here is not a value, it's an NA. So that's how you can evaluate certain things within your R. Okay, let's have if, and then we have else if. So if you want to have multiple conditions, conditional statements within your codings, is that you can actually get to use it. So else if can also be used. Else if, so it's gonna look at something else. If we have a value, let's say we do have a value, right? So else if our ozone layer, right? Let's say it is less than having a gauge less than 25. Let's try 40 is less than 40. I want you to print the following up for me. What? Print ozone level is low, right? So this is the one that we're gonna be using now. This is the one that we're gonna be using for now. Sorry, just got it. So it's missing. And then what if we have a different one? So we're gonna have another else if. Else if, another else if. Need these ones to be next to each other. Else if our ozone, again, ozone layer is let's say less than 100. Less than 100. Ozone is less than 100. What are we going to be doing? I need you to print. Okay, that's a lot of, so I'm gonna cancel all of the stuff and to long press the enter button here. So for ozone layer, so kill brackets, enter. Print for me. Print for me. I want you to print for me. We have maybe moderate ozone. Moderate ozone level. Moderate ozone level. Right. Moderators on level. So this is what I have here. And then the last one we're going to have is the else statement. So the else statement has to close everything that we have here. That's what it is for. It's supposed to come here. It's supposed to be after this. So always watch out for that. The else statement becomes the last statement that we get to put. So the else statement will just maybe say anything else, anything else that is everything that is above 100, right? That is 100 and above, 100 and above. I just want you to print, just print for us, high ozone level. Ozone level. So sorry for the way I've been going through this slowly. I was just getting a little bit distracted, but this is what we have, right? So I'm just gonna change here to 1, right? So we have one that's 67. Is that it? 1 is 41, right? So looking at 41. So if I have 41, this one is less than, so I don't need a 1, I need a less one, so I can print this one out first. Ozone is less. So I need a number that's less than 41. I look for a number 36, so 2. Let's pick 36. So 2, right? I'm just gonna run everything. I'm gonna highlight everything so that it changes how it saved that number above. Then knows that ozone has been giving a different value now. So run everything. Ozone level is low, right? Because it's below 14. That's one we picked. We picked 41. Now let's pick a number that's above 41. What do we have that's above 14? That's above 40. There's 45. So I'll pick 29. So 45 is above 40. So 29 here, right? Then I'm gonna revalue the variable ozone layer to 49. That's why I'm highlighting everything. Right, and then it says our ozone is moderate ozone level. That's what gets to be printed for us. And then I'm going to choose a number that's above 100, right? So I'm going to look here for a number that is above 100. So we had, notice 115. I don't know where it just disappeared to. There we go. We have 62. If I'm not mistaken, 62 is 135. So I'm going to pick 62 here. 2, and then I'm just going to highlight everything so that my ozone layer gets to be assigned a different value. So high ozone level, right? So that's how you can maybe help out in understanding all the numbers that we put in there. So you can actually have an iteration that takes place. We'll be just going through different values, through different numbers, and it just be scanning the levels that we had. So on this particular day, you can ask it to tell you what ozone level did we have on that day. Was it too high? Was it too low? Was it too high? So you can actually help you out maybe in planning your days and planning some conservation activities that can help reduce the amount of pollution that is produced out there in our environment. So you can actually use this one as a data analyst and be able to tell people, right, like on a certain particular day, this is what we first, and this is how our ozone levels are increasing by each year round, right? So you can have that average, as we've actually talked about how you can do your average, or you can do your multiplication, I can do all that. And then you have everything displayed out there for your stakeholders to interpret and see what is at stake. So yeah, that's about that part. Now that we've covered some basic things, what I'm going to do is maybe just clear this one up, right? Just going to clear this one up a bit. Okay, just going to clear this one up a bit. I think I'm done with the equality. We're going to try a different one later on. So we've covered conditional statements. So this is how you deal with conditional statements, right? So the if statement, the else, and the else if statement. So the if statement comes first, followed by the else if you have a number of conditional statements that you need to be evaluated. And then what ends is always the else statement. You can't have the else statement before any of the statements that I've mentioned. So you can't have an else before an if statement, you can have an else before an else if statement, you probably run into an error. So the else statement is always the closing one, and the if statement is always the opening one, and then the else if statement is always in the middle. That's how it goes. It's always in the middle. That's how you deal with it. So if you ever try to rearrange them differently, you probably run into an error as a result of it. Okay, so we have covered that one. The next part I want to try to cover is dealing with packages. So we have a number of packages within R that we need to look into, right? And I said R comes with different packages within it. And if you just want to maybe run through them, right? So the next thing I want to cover here is the packages in R. Packages in R, right? Okay, capital letter R here. So, okay, that's the wrong spelling of packages. There we go. I think it makes a little bit sense. So packages are basically things that you work with R. So packages can be the TidyVerse is also a package. So these can be functions or tools that you can use in R to help you out with your data analysis processes. And they can also be data sets that you can actually play around with, learn with, practice with mostly. So all these are packages that you can work with in R, right? So a typical, let me just say, a description of what they are is that they are reusable functions, right? So you can actually use them. Someone has already used them, someone has already built them for you, and you can just grab them and start using them again and over again, just depending with how you dealing with your data analysis process, right? So these are reusable functions, documents about the function as well. And they can also be, like I said earlier, on simple data sets, and you can actually use some of them to maybe test your code and see if it's working how it is supposed to, right? And then these packages can be divided into two. So if the base are packages and the recommended, which are basically loaded packages, but they are not installed. So base are packages that are basically installed for you. You can actually just get right into using them without having to install them. These are called the base packages. And just write that one down so that nobody gets lost when dealing with them. We have the base packages. So base packages. Sorry, this was supposed to be, should make sense to have this one, and then tab base and recommended. Guessing this one is to have one C and a double M. Recommended packages, right? So for base R packages, they are already within R and they're already installed. For you, recommend packages, they are just loaded in your R console, but they are not installed. So you might need to install them. That's why we use the install.package function. If we need a certain package within R that is there for us, but we actually don't. So recommend packages are packages that have been recommended by R for you, right? Whenever you're doing your data analysis, this is what you can actually use, right? So they are recommended for you. Okay, so let's just have a quick look of the number of packages that we have in R. So we have, how do we do that? So we can just say install.packages, and then you don't have to write anything in here, and then just run this whole thing. So let's just run it and see what comes up. Wonderful. So all these are packages within R, right? They're all packages within R. And within this, they're divided into either a base package, right? Or you can find the rest that are not base, that are probably recommended for you. So you can actually install these ones, depending on how you are going to be dealing or manipulating your data set, right? So we have all these that you need to take into consideration. So installed packages, these are all the packages that you have in R. You can go through them. You can have a quick look at all of them. And I also love that they also get to have the last part that I love is the priority column, right? So priority column, they actually help you see if they're really that of priority. You can actually have them, you might need them, right? So the priority gets to tell you if you truly need these ones and have them installed within your R package, right? And for all those packages that you have, right, within the base R, you can actually, so let's just look on this other side so you can see what I'm talking of. If I click here in packages, I can see all these packages just popping up, right? So whatever that is tick here, right? I didn't install it. Now this one just got detached for no reason. I was supposed to do it. If I need it back, I'll have how to just code upon this one, the library package, right? So I already have it, right? And if I want to open it up, I just have to tick on it, right? So anything that has a tick means it's ready to use, right? So I have the data set package. Remember, last time I had to call upon the A quality data set. I only had to call upon it, right? Because I actually have the whole package of the data set with it by console. And then within that, there's the A quality. So we're going to look at the different data set that we have within that one. So anything that has a tick on it is already saved out for me. Anything that doesn't have, I don't have it. So if I put a click on it, it's going to run the library function for me and then call upon it. So that's loading the package within the console so I can actually make use of it. So if there are some number of packages that you have that are not ticked and you just need them, you can actually use that one to have them. So you can see how I have a few of these packages, right? They're not much, they're just little. One of the most important packages, we're going to look at it, which is the TidyVerse package. It's one of the best packages that you can actually use, and it is a number of packages within it. The TidyVerse package is a package with other packages within it, right? So it's actually the most powerful package or the tool that you can use for your data analysis process. And if you want to do a lot of data analysis, this is the one that you need to go to. So it is all the tools that you need for your manipulation of your data, for your cleaning your data, for your visualizing of your data. So just gonna go through it later on, but right now I just want you to be introduced into this one. So let's just clear this one up. Just clear this one up. Okay. So hey, so if I'm not mistaken, I think from our previous lecture, we had managed to cover a number of things, right? Um, so one of the things that we covered, we managed to look at different operators from arithmetic operators, conditional statements, as well as logical operators. Right now, we had to move on and talk about packages. So for packages, I believe that we have a number of packages, so this might feel like we've already covered it, just in case I had not clearly explained how we get to deal with any of these. But for packages, we have a number of packages that we actually get to deal with. And I managed to describe the different types that we have with the base R packages, which are packages that are already installed within R. And then we have got the recommended packages, which are packages that that we have in R, but they're not installed. So they're already loaded, but they're just not installed. And all you have to do is to run the install packages function and have them within your R. You can basically just click on, so if I come here on my far right side of my console, there's this section where it says packages. If I click on any and then just tick on any of these, that means it will be loaded within my R console and I can just start using it. And how you do that, we have been explaining about it ever since we started, that we actually make use of the library function. So whenever we make use of the library function, it helps us in dealing with that part. Okay, so that's how we load our packages, which are already within our R. But if you don't have them, we need to run the install.packages, then the name of the package within the parentheses. So, yep, that's about it. So, what else do you get to see when you're dealing with packages, right? If you have got an issue of a certain package that you can't seem to understand, we manage to have the following. So we need to just have help on view. Let's see if this one would run. Fantastic, it did. So you can just have a question mark before the name of the function, and then just hit enter, and you should be able to invoke the help function on that particular package. Then you get a whole description, what it's all about, what it does, and things like that. So if you've got packages online that works on R that you don't understand how to use them, you can actually run that help function, and to help you out with the description and the capabilities that that package can actually go. Yeah, so that's about our packages. And if you need to have like a huge comprehensive of the different packages that R has, so that you can work with within the R console, you can actually check out Cran. Just here. Yeah. So Cran is basically like a repository of different packages, documentations, codes, and things like that for R. This is where you find everything in one place, right? So CRAN is short for Comprehensive R Archive Network. So if you need more packages, you need to understand the different packages that works now, the different codes, the different tests, and all that other stuff. You can actually make use of CRAN. So right now, I think we want to look at one of the most powerful packages that we have, which is just get a new I can just open oh open a file here. Then I'm just gonna choose cell script. I think we worked on this one last time. And I have it running. Fantastic. So these are the things that we covered earlier on. So let you go. So if we run the installed packages, what we're gonna get is basically just run it. All the packages that are installed within R, right? So if I do this, then drag this one a bit up, you have every package within R that you can actually make use of. All these packages, you can definitely make use of them. And if they're not loaded within R or installed, I'd have to run the library function on the package or the install.packages on that particular package that you need. Okay, so I wanna move on to one of the most powerful packages that we have, which is known as the TidyVerse package. So the TidyVerse package is one of the most powerful R packages that any data analyst need to be aware of. It's a package that houses other packages within it or other tools within it. So if you need a package that is to do with the data manipulation, if you need a package that has to do with data cleaning, if you need a package that deals with sorting, if you need a package that deals with opening a certain file that is saved in a way that R does not understand. If you need a package that deals with manipulating dates and time, if you need a package. So if you're a data analyst and you have to work with all these different types of packages and deal with number of problems that your data might have, and you need to visualize your data and all that stuff, the TidyVerse package has got something for you. So it's regarded as one of the most powerful packages that you can actually make use of. So right now we've got like the TidyVerse package. I'm just gonna go through it and how to get it. And just to have maybe a little bit of a description of what it looks like, I've given you what it looks like, but a definition of it is that it's like a system of packages in R with a common design philosophy for data manipulation exploration, and visualization, right? And that's all you need about it. And if you've got like other packages that you don't understand, if you want to check me with audacity and things like that, that's where Crane comes into play, right? So Crane is like, this is where you can find pages that are authentic. You won't find problems with them. So the TidyVerse is like part of that. You can go online, search on Crane, and see what it does and the number of packages that it is. So I just want to, let's just go back on the packages list here. You can see how I've got like a few number of packages here, just a few number of packages. If I were to run the TidyVerse package, this whole thing is will be flooded with packages, right? Because I said it's a system of packages. That's what TidyVerse is. A system of it is other packages within it. So if you run this one, you've got all the tools that you need to go around and play around with your data analysis process. Okay, so let's install our TidyVerse package. So one thing I want to do is install dot packages, right? Then this one gets to finish it out for you, and then always make use of the codes should be in you all the time. TidyVerse. So install TidyVerse. If I run this one, it's gonna go through this whole process of loading the package, and then it's downloading every other package that is not within the ARA package, within the ARA console. So you can see how I still have got like a few number of packages on this side. If you look at it when it's done here, you see how this one is going to be flooded with a number of packages within it. So let's just give it a little time and see how that one will be flooded out. Okay, now it is installing the package. It was downloading them. Now it is installing. Now all these pages that are just popping up there, you can basically get to, they can help you somewhere, somehow with your package problems, right? If you've got data set that is with a certain problem, just know that um, TidyVerse has got a package to deal with that particular problem with your data set. So just like I said, on just go and Crane and look it up and see what you can make use of in the TidyVerse to help you out with your situation. Okay, it looks like it's getting done. It's installing all that. Okay. TidyRM, one of the packages that we make use of when you want to make your data tidy, clean in short, make your data clean. Okay, now it's done. Here's what I wanted you guys to see. Okay, you can see now how this one has got like a number of pages. Now we have lots of packages now, lots of them. Just gonna save them up. So library, and then TidyVerse within it. TidyVerse, library, TidyVerse. Okay, they just use the console. Fantastic. Okay, so looks like dplyr, reader, string error, table, tidy, loop, gplot, focus, and per. All these packages have now been attached. That means I can actually make use of them. And then there's just a few conflicts there. Looks like the filter package from dplyr, leg, and stats, and so on. All these already existed in R. But what happens is that if there's a conflict of packages, R will take priority of the last package to be installed. That's what it considered to be the most up-to-date package. So it's kind of, yeah, just kind of telling us that it has done that. It has masked the previous version, and then now it started to consider some more updated version of that package. So it's not a big issue of it. No need to worry much about it. Okay, so we have all these packages now. So these are like really important packages, and I'm just gonna try to go through all these packages. So there are 8 of them, right? If I'm not mistaken, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Wonderful. Looks like we've got a whole lot more, but these are like the most important core TidyVerse package. So we have the ggplot2 package, we have got the dplyr package, we've got the focus package, we've got, and all these packages are really, really important because what you can do with the TidyVerse alone, as you can see right now, is that you can actually use any of these packages to import your data, right? So read Aaron is going to cover that part, right? And then you're going to be able maybe to clean it up. You want to clean up your data. TidyR is going to do that for you. You need to transform your data. You need to visualize your data. You're going to communicate your data. And any one of these is going to be able to perform a certain function for you. And within these 9 packages, there's like the 4 main packages of the TidyVerse, right? That you're mostly going to need to know all of. The first one is the ggplot2, right? So what this one does for us is that I love the way that there's already a plot in it. So you're dealing with the visualizing of your data, right? So plots, that's what it is responsible for. You want to visualize your data, you want to see what you have, what is looking like, where each data point falls, and things like that. The ggplot2 is going to be the important, amazing package for you to make use of. And then we've got the tidyr, like I said earlier on. It's a package that you can use for cleaning up your data. So that is to make tidy data. And earlier on, I did mention that if you want to read a package, when I import it, readr is the go-to package for importing data such as a CSV file, an Excel file, and so on, right? And you might need maybe to specify the column specification, but it will automatically, in most cases, be able to do that for you. Then we have the dplyr package, right? So the dplyr package offers a constant set of functions that can help you complete some common data manipulation tasks, like maybe selection function, which picks variables based on their names, filter function, which finds cases where certain conditions are met, right? So we did talk about the if and R statement, right? And then this one can actually get to run through your whole data set and then help you with your selection or a filter function. You might need to work with certain data. So you can select that I want to do with this, or you can filter out certain data, then say I want to work with this type of data. So you can see that you can do almost anything that you wish to do with your data set just by importing and installing the TidyVerse package, right? So this is like one of the packages that you can actually make use of. But we do have other packages, like I said earlier on. The main 4, I've talked about them, but the remaining 4, like table, we do have table here. This one, okay. On this one here. So we have table. You can actually use table if you want to work around with your data frames. You've got per, you can actually use it if you want to work with the vectors and functions, and then string around. That's one of the most important keys that you can dive into and start using if you want to work with strings. And then forecast is amazing. You can actually use it to solve vector or vector or categorical data in R. That's where it comes into play and help you out a lot. All right. So after we have covered this part, now you have an idea of how to get a package into R. So just by installing the TidyVerse package and then opening it up through the library function, you have now learned how to get a certain package into R. You can actually do the same thing for a data set, right? So we're gonna do that. But right now, I want to introduce you guys to pipes so we can cover some of the things that we might have failed to cover last time. So I'm gonna do that now. So what is a pipe, right? Let's just skip this one and then just go and talk about a pipe. So this one is gonna help us play around with our, we wanna put into use the TidyVerse package. And then when I do that, I also want to cover a certain part of this section of this tutorial, which deals with the pipes. I had already introduced you to it earlier on, but we're just going to wrap it up. In fact, we are opening it up and see how you can actually make use of it in this tutorial or in your everyday uh, data science life. Okay, so earlier on we introduced pipes as just type that on up. Pipes is a tool for expressing a sequence of multiple operations, right? And we kind of hinted out that the only way that you can call upon a pipe is by using the following symbols all together, right? A percentage greater than another percentage. That's how Aaron knows that you're dealing with a pipe. So what does a pipe do? right? So it takes the output of one function and makes it an input of another function. So instead of having functions within functions, what is referred to as nesting, both in R and in Python, right? We can have a function within a function. Instead of having that, we can have a function that just takes the output of one function and makes it the input of function in a very clear, concise manner, right? So that means your code will be just straight. It makes sense to have it. So coding performing a function within a code, performing a broader function, that's what a nest actually does, right? So we are having like a code that performs a certain function within a code performing a broader function. So I'm just going to give you an example of that so that you don't get lost. So let's try the first one, which is nesting. I want you to see what nesting is. So nesting here. I'm going to try to run this one up. So like I said earlier on, besides just having, okay, I need to make this one longer, so I can see here. Good. We're gonna create our path first. We're gonna go through step by step on how to do with it. So we're gonna use the same script that we're using here and maybe save the following. Let's save data here. So my data, I can actually do this one since I already have it. You can just call upon the data function, then say I need the following function. I need the following package, my data set package to the growth. Right, that's what I'm gonna use. So it ran perfect, no error. And then I'm gonna need to reveal it so you guys can see what I have here. It gets lost in the middle. So tooth growth, and I'm just gonna run it. And there we go. Amazing. So, okay, I need to close this one. There's a lot of it. So as you can see, this is what's within the data set of the tooth growth. We have the len, I'm assuming that's length, supplement, and then DOS, right? So these are the variables that we have, and this is the data points that we collected for each, right? Okay, so that's the data set I'm going to be dealing with. So now, since I've already installed the dplyr package and I already have it, right? If I say library, that's if it's not within my library, and then I say dplyr. But we're gonna try the dplyr package. And there's an error here. Dplyr. There's only one. Why can I see an error here? I'm gonna run this one and see if I have an error. Yep. Dplyr, I'm gonna find the function library. Okay, that was typed wrong. Suppose we have this library. Okay, so your English is leaving already. Okay, so this is what we have for library. No more error. That means I've already opened up the dplyr package. Remember, kind of covered this one. So the dplyr package, like I said earlier on, what it does is amazing, right? So the dplyr package can actually offer us like a custom function that helps complete some common data manipulation tasks like select function and the filter function. So in this one, I want to use the filter function mostly, or I can use both, right? But I'm just going to start with the filter function, right? So by calling the dplyr package, now I have the capability to use what it holds, the code that it has within it, right? Which is one of it is the filter function. So the filter function, that's what we're going to playing around. I'm going to say my filter data. So I'm going to have here filter data. Okay, I think I'm making an error here. Filtered slash data. Then I'm going to assign the following variable. Let's say filter here. So I'm calling around the filter function, right? Filter is a function. It came. Tell me that I need to put data in it. So the data that I'm going to use is the tooth growth, isn't it? And I use the tooth growth data set. Then I'm going to put a comma, right? And then I'm going to have DOS being my variable here. So I'm getting the DOS from. I'm saying, look at DOS within that data set. I want you to consider a DOS that is equal to 0.5 only, right? So I'm just gonna run this one, see what happens. Perfect. So now I've filtered data set. I've filtered data here that has got everything within this, but correspond to a dot that is equal to 0.05. So let's just have a look at that data. Filter data here, and I'm pressing enter. Then you can see everything here is 0.5. Let me see if I can enlarge that. So I've only data that correspond to a dose of 0.5, right? Now, next thing that I'm going to do here is to arrange the data, right? So I want to arrange my data so it starts from a certain order, or it is a certain order within it. So arrange, filter data, and then what am I going to use as a mechanism for arranging that data? I'm going to use my len, right? Because I already have it, len. So anything that is going from the lowest to the highest, that's how it's going to be arranged, right? We're moving from the lowest to the highest, right? Unless if I put a negative on it, then it's going to do the opposite of it. So just press enter and see how our data got arranged. So we've got 4.2 being the minimum length, and then 21.5 being the maximum length within the dose of 0.5, right? So we've covered this part. So this is like using the filter function within the dplyr package that is within the TidyVerse package, right? Now, let's see if we can work around with the nested function for what we have just done. I wanted to introduce you guys to the nested function, but in order to do that, I wanted you to see the tools that I was going to use before I move on to the filter function. Right. So here's the first one. So we're going to do a nested coding, what people actually do, a code within a code, right? So we're going to have arrange being the last one that we dealt with. Right. So arrange earlier on, we had to use the data that we got from the filter data set, right? But I'm not going to do that. I'm going to write it as it is. So if you look at filter data set here from top, here's a filter data set. It consisted of the following code. So like I said earlier on, instead of having to rewrite all this, we can just assign a variable to it and then just use this variable next time we have our code down there. But right now, I just want you guys to see how nested function is and why it can be time consuming for all of us. I'm just going to copy this and then paste it in here. So it's going to take this whole data set, right? And then I'm going to ask you to arrange it by len. So this is basically what I've done. I've nested a code within a code. So that's nesting of a code. So if I run this one, I'm going to get the same results, right? 4.2 and all of that, but it's just that I've decided to have a code within a code. So that's nesting, right? Let's talk of how we can use the pipe operator to help us with what I've just done here. So I'm going to do that on the next part, and here's what we're going to do. So in how you can actually call upon the pipe operator in an arrow console environment is to use the Control Shift M button, right? It brings that pipe operator for you. So Control Shift and M if you want to do each click for a percent greater than another percent. It might be time consuming, but if you just go Control Shift and M, the pipe operator will pop up for you, right? So let's use that now. So I'm gonna have another filtered, but this one's gonna be properly done. Filtered truth. We'll just call the filtered truth, right? And then I want to assign in the following variable. So here's how it's gonna go. I'm gonna ask you to take the truth data set, right? It's gonna take this truth data set, and then it's gonna use, that's where the whole idea comes in. And then you're gonna do this, and then you're gonna do that, and then you're gonna do that. Because it's using the output of one function and making this an input of another, right? So take the truth growth data set, and then so Control Shift, then M, I have my paper border popping up, and then take that, right, and filter it. Filter my data set. Okay, I can't choose that one. I need the whole thing. I think I've already copied this, haven't I? I want you to filter my data set. But the difference now is that I don't need to write truth anymore because it already knows that we're using the truth growth data set, right? It's taking that as our input, right? The truth growth data set is being taken as our input. So future no longer needs to include the data set anymore because it already has it, right? But it's just going to use DOS is equal to 0 0.5. 0 0.5. And then we're going to close here, right? And then after you filter this data, I want you to arrange it, right? So we're going to do that, okay? Long process. I'm going to arrange this one. So it's going to take the output of that filtered data. Okay, so when we took a little break, we were looking at nesting of our data, and then we covered that part, and then we covered like a whole process of going through the step by step of what I'm doing right now, right? So we had two things that we covered. The first was the normal path, right? Of just doing one code after the other, saving variables and moving to the next. Then we had to go through nesting. And then when we were done with the nesting, we said, let's see how we can better apply this one using a pipe operator, right? And we say that the filtered, right? So we're saving this one, a variable filtered truth, but how we're doing it is kind of different now. We are calling upon the data set first, the truth growth data set, and then we're saying use that as an input for filter function, right? And then within the filter function, I want you to consider a DOS of equal to 0 0.05. And then I want you to use whatever results you're going to get in here, right, as an input for a range function, right? So the range is going to use a range using len. Len is our purpose. I'm just going to run this and see if anything will pop up for me. So let's say filtered truth. It came as a global variable, and I'm going to give a quick enter to it, and then you can see that we did manage to get the same result as we did alone. So everything that has been arranged in order, but the difference is you can see how this one is more straightforward, clean, and it makes sense for someone else who will be reading through it. So I should have used this one on a script so that I can save it so someone can actually go through it and have a quick and amazing look at what I was trying to do there. Okay, so that's about the introduction of a pipe, right? And then we managed to use some of the functions of the TidyVerse package, right? So we can always make use of this whenever you need to do a lot of stuff in it. So let's say you are more of an experienced data analysts, right, who is versed in our programming. You might do the same thing. Let's try something that is a little bit more experienced. Don't worry about this one. We're gonna have a look at it later on. What I'm saying, this can kind of motivate you to be more in terms of what you do. So go ahead and look at the average tooth length, right? The average, let's have an AVG. Then tooth length, right? So for my average tooth length, I'm gonna do this something that I did earlier on, right? Uh, let's have filter our data set first, right? So we're gonna have our data first set. Just copy everything that I did here, then bring it down here, and then work with it from there to see what I can get. Or let's just go through it so that you guys can maybe grasp it more. So tooth growth, I need that data set to pop up. Did it show? It did. Tooth growth, take that one and then make it an input of the filter function. Right, so when I use that, the filter function, so I need the filter function from the apply here. But how are you filtering this one? You're using DOS is equal to 0 0.5. Right. But I can actually use a different one just to make it nice. SAP, so you don't cram things here. So let's use SAP. SAP is equal to VC. It's equal to VC. Now we are dealing with strings, so make sure you keep that in mind. When you're dealing with strings, make sure that you watch out for that. So VC, or you can have OJ, and OJ. Let's make OJ. OJ looks nice. OJ. So anything that meets up SAP is because OJ is the one that we're gonna get from it, right? And then I want you to take that one and use it then as an input to group by. So group by, let's see where group by is coming from. That's a wrong spelling of group by. So group by is from dplyr. That's another function that you can make use of, right? So group by. So we're gonna group our data, right? And this time we're gonna group it by len, right? It makes sense to group it by len. So I'm just gonna put len in here. And then once you've grouped our data, I want you to take all that output and make it an input and summarize it up, right? So summarize is another function that you can also find in the dplyr package, right? Then summarize everything. Sorry, I need to make sure this is the right spelling. So I'm supposed to click, let's see if Z will pop up. Summarize from dplyr, that's much better. So I just use an S, I have to use a Z. So summarize, it's gonna take that data, right? Then it's gonna ask me what you want to use to summarize. So I'm gonna ask you to create another variable within the result I'm gonna get and call it the mean length, right? So for my mean length, I want you to calculate the mean of each data that you have grouped, right? So mean comma length. And if you ever run into any now applicable value, I want you to just remove it and have it replaced with maybe T. That's going to help us out with that. And then I want you to use a group and drop everything else, right? So that's what we're going to do. Don't worry about it. Like I said, it's just for experience, guys, right? That this is what you can do. I want you to see how powerful the dplyr packages or the TidyVerse packages when you're doing your data analysis stuff. Let's just run this and see if I didn't run into any errors. I'm hoping I did not. Fantastic, I did not. So let's call up on this whole thing again and see what I'll get from it. Wonderful. So here's what I've managed to get. Everything was arranged by len, right? And then from len we had the mean length 8.2. Then other things that you get to be replaced by all this, right? So we managed to get our mean length for everything, 9.4, 9.4, 9.7 with that for 10, 10, and so on and so on and so on. So it grouped everything and had replaced as that. So let's say I've used, so I just want to try something and see if I run into any error with it. Okay, I'm in the console, so I can't do that. So I just have to pull up on that and play around with, okay. Fantastic. I can actually do this. Perfect. Let's bring back DOS is equal to 0.5, right? Then I want to play around with group by. I'm going to use something different. Here I want you to group by let's use sub. Sub look to have something amazing in it. So let's see what we'll get from it. Okay, let's just run this, see if it would be an error. No error. Good. Then I want you to give me the results of that. Fantastic. You see, so we grouped our data on based on two things that we have. So we can see we have VC and we have OJ, right? VC and OJ. We're comparing these two that have got a DOS of 0.5, right? So it did that, but then it was looking at the mean length of OJ and it got this one. Another mean length of VC and got this one. So just by adding everything that is associated with VC, but the dose of 0.5, and that is associated with OJ and with the dose of 0.5, adding each separately, dividing by the total number of items that we have, managed to get these for our results. So you can actually use this to visualize your results with it. Okay, so we have covered that part. Let's see what else we can actually get to deal with before I move on to the next one. Yeah, I think that's about for this lesson, right? So we have covered a lot of things, and I would really appreciate if you guys would go to practice further on the things that we have covered in this tutorial.